This is our paper called FCBFormer, Hierarchical Fully Convolutional Branch Transformer for Occlusal Contact Segmentation of Articulating Paper. Now, occlusal contact identification is a mandatory test in dentistry to identify the areas on the occluding surfaces on the posterior teeth that make contact, or the biting surface on the back teeth that make contact. The most common method of occlusal contact identification is articulating paper, as it is cheap and easy to use, but it is inaccurate. Occlusal rock is considered the gold standard test method due to its high accuracy, but it is expensive, so it's not often used in clinical practice. Now here we can see a figure of articulating paper with its corresponding mask in red, the gold standard mask in green, and the agreed areas of both in yellow. The large green and red areas shows the inaccuracy of articulating paper methods. Now, if we want to train a deep learning semantic segmentation model to detect the true occlusal contact locations in articulating paper images, we cannot directly use the gold standard masks due to the significant medically false negative indications in green, which we cannot identify in an image with only one row of teeth. However, we can detect the medically true positive indications within the total articulating paper indications, or the yellow locations. We generate medically true positive and medically false positive multi-class masks by taking the articulating paper masks and finding the intersection between it and the spatially calibrated test and retest of gold standard masks for the same patient, where the test and retest gold standard masks were used due to there still being a small disagreement between gold standard tests. We added upon the hierarchical cross-entropy loss function by Muller et al., which works by splitting the classes into a hierarchy, with leaf nodes of the hierarchy being the classes detected by the model. For us, this is background medically true positive, medically false positive, with non-detected parent class, which for our setting is the original articulating paper masks, which we refer to as full contact masks. For any given loss, it is calculated for the leaf nodes first, at level 0 of the hierarchy, and then calculated again on each subsequent level up the hierarchy, until the base classes are reached, where the parent class is the sum of the probabilities of its child classes. The loss at each level is then summed to give the hierarchical loss value, which we use the sum of the hierarchical dice loss and the hierarchical cross-entropy loss for our final loss function. This allows the model to adjust the weights in regards to the individual detected classes, as well as how they interact with each other with regards to the parent class. We also adopt FCBFormer by Sanderson et al. And adapt it for multi-class segmentation. This employs a pyramid vision transformer and fully convolutional network ensemble to retain both global and local features. Now, our results show that our model consistently outperforms UNet and the non-hierarchical multi-class version of FCBFormer for both medically true positive detection and full contact detection. Qualitatively, multi-class FCBFormer often overpredicts and hallucinates medically true positive contacts. UNet underpredicts the contact areas and sometimes misses contacts, while our method has more balanced prediction but still underpredicts contact areas and infrequently hallucinates or misses contacts. Now, lastly, we conducted an independent observer study on a 128 image subset where we compare our model predicted full contact masks and 4 independent dentist masks of the same task against the original full contact masks. Our method significantly outperforms all dentists while taking significantly less time to produce the masks. Thank you for listening.